All right, here's our problem for today. It says the table presents the average points per game, PPG, for the 30 NBA teams in a 2012-2013 regular season. And it gives us the data. And it's asking us to create a histogram to display the data. All right, we're going to create this histogram on a graphing calculator. And in addition to creating the histogram itself, we're going to go over general calculator skills that we need to have for this particular class. All right, so anything you do data-driven in this class, which is quite a bit, you want to do the same set of keystrokes to get your calculator ready. First, I'm going to go to Stat, Edit, and if there's any old data in here, I'm going to clear it out. The way you clear out the data is you put the cursor on the title of the list, hit Clear, go back down into the list, and the data will go away. I'm going to do the same thing with L1. What you want to try to avoid is don't hit delete while the cursor is on the title of the list. It removes the list from your calculator. We can put it back, but it's an unnecessary step if you just follow these instructions. Okay, the next place I'm going to go is y equals. If there are any old equations in here, I'm going to clear them out. I'm going to scroll to the bottom to make sure there's no hidden ones. And if that plot 1, plot 2, or plot 3 is highlighted, it means there's some type of stat plot turned on. We want to turn it off. So right now my plot 1 is highlighted. I'm going to put the cursor on plot 1, hit enter, and go down. Okay, the last thing I'm going to do is I'm going to hit zoom, and choice number 6 is zoom standard. What that does is it takes you to a -10 to +10 in both the X and Y direction. Not that we need this particular screen, but if there were any weird window dimensions left over from a previous problem, that'll clear them out. Also, if you didn't quite follow instructions the way you should have with what I just asked you to do, you'll get an error message or something won't be quite right here. All right, so now the calculator is ready to start this problem. I'm going to go to Stat, Edit, and I'm going to get this data in the calculator. So it'll be 98, 96.5, etc., etc. There are 30 total numbers that need to get put in here. In the interest of time for this video, I already have that data in another calculator. All right, so all 30 numbers are in L1 in my calculator. Now, one thing that makes this list perhaps a little bit more awkward than we'd like is the fact of the names of the teams are listed alphabetically. So if you're looking for a team, that's nice, but the numbers are not in numerical order. So one thing that's helpful when you're dealing with data in your calculator is the ability to sort your list. So what I'm going to do is I'm going to go to Stat, and I'm going to bump one menu down to Sort A. That stands for sort in ascending order, from smallest to biggest. I'm going to choose Enter. The calculator is waiting to know what list do you want to sort. Slide this up a little bit here. The L1, L2, L3 are all the second functions above the regular numbers here. So I want it to sort list 1, and I hit Enter. And when I go back to Stat, Edit, that list is in order now. So it's going from smallest to greatest, which for certain calculations you need to do, certain observations you need to make. That's good to see it that way. Okay, next thing I'm going to do, I'm going to get summary statistics for this data list. Stat, bump one menu over to Calc, and I'm choosing the first one variable statistics. The calculator wants to know what list, so we're doing L1. That's already filled in my calculator. I think the calculator defaults to that. If it's something other than what you want it, use the L1, L2, L3 second functions down here. The frequency list we're leaving blank. We're going to talk about frequency lists in combination with one variable statistics at a later time. Choose Calculate, and I'll do a run through in terms of what this stuff stands for. Okay, the X with the line on top, That's called X bar, and that stands for your arithmetic mean or your average. That's the Greek letter sigma, X. That's the sum of all the items in a list. The third one is the sum of all the squares of everything in the list. Now that might seem something that's a little odd that you would want to know, but it turns out that the sum of the squares is a small part of several different statistical formulas. So there is a reason to want to know that. The next two guys, the S sub x, and that's the lowercase Greek letter sigma x, those are measures of standard variation. It's how spread out the data is. We're going to talk about standard deviation in detail in a few lessons. I'm just indicating that that's what those stand for. N equals 30. That's how many items are in a list. And then if you scroll to the bottom, you get what's known as the 5-number summary. Your minimum, lower quartile, median, upper quartile, maximum. We're going to talk about that in a future lesson. All these numbers are going to mean something at some point. I'm just going over the keystrokes of, well, how do you get to this list, and a quick overview of what the stuff is. Okay, based on what you guys know right now, what would be most important is that mean and the median. Those would be the two numbers that would be on the page or on this screen that you would want to identify. As far as the classic statistics you knew prior to coming into this class, mean, median, mode, and range. For the range, you can do the maximum number minus the minimum number. It doesn't tell you directly, but it gives you the ability to figure that out. And if it doesn't tell you the mode in the summary statistics, but the fact that we've sorted the data, it makes it a lot easier to go through and identify the mode that way. All right, now on to creating a histogram, the actual specific instructions for this problem. I'm going to go to second y equals, and I'm going to, that gets you to the stat plot menu. They should all be turned off at this particular point. That was one of the things that I asked you to do when you first grabbed the calculator. We want to choose the first one. We want to turn it on. We're going to choose the histogram option. Histogram kind of looks like a bar graph. Our X list is L1. The frequency is 1. This is one of the quirky things about the calculator. That last thing we did with the one variable statistics, we had to leave the frequency blank. In that menu, the frequency being blank defaulted to 1. You didn't want to type it in. I'm pretty sure it gives you an error message if you do that. But in this window, you have to have the frequency 1. If you have it blank, I believe you get an error message. All right. The next thing we need to do is set up a window in order to be able to see this particular graph. Well, I call it a cheater starter window. What I'm going to do is hit zoom and then bump down to 9, zoom stat. What this does is it creates a window for you based on what the calculator thinks might be a good idea. What happens is depending on the graph that you're trying to produce, like for box plots, which we're going to do in a day or two, the calculator is pretty spot on. It tends to give you a solid window for box plots. For histograms, it tends to not be so good. What I'm going to do is go to Window, and I'm going to look to see what window dimensions the calculator set up. So we went from 93.2 to 108.25. An X scale of 2.15. That means our bin width is 2.15. That's how wide the interval is for each particular bar of the histogram. The Y min, the Y max, Y scale. Okay, X res, we don't do anything with. Leave it alone. Whatever the default is, just keep it that. That delta X, leave it alone. Whatever the default is, we keep it as is. The trace step 0 point whatever, leave that alone. We care about the X min up to the Y scale. Now, typically what you're going to need to do is to get this graph that you create on your calculator onto a piece of paper. Getting that onto a piece of paper with those window dimensions is awful. We're going to need to clean that up a little bit. All right, so I'm going to go back to my summary statistics for a moment. Oop, I need to get those back again. And I know that the minimum value in this is a 93.2, and I know the maximum value is a 106.1. So what I want to do is use those to help me identify a good min and max for my histogram here. So we got 93.2 right now for the minimum. Okay, what if we bump that down to an even 93? And we only have to go up to a 106, but we still need extra room potentially in that bar. So what I'm going to do is just bump that up or round it to just a 108 and see what I end up getting. We might want to go down to a 107. Not really sure about that. There's not an exact science to this sometimes. It's a little bit of a guess and check. Okay, X scale of 2.15. I definitely want a cleaner number with that. Let's go 2. In order to make that an easier number to identify, we'll make that just a -3. We'll round that to 12. And in the Y scale, we'll tick mark every 1 unit. Okay, let's see what we end up getting. All right, so we got this little bit of extra space left over at the end. I'm thinking that's because we started with an odd and finished with an even, just so it fills up the screen a little nicer. This is a little detail that probably doesn't matter, but I'm going to go back to Window and make that Y max 107. All right, so that's a pretty decent looking histogram right there. One of the general rules of thumb is you don't want less than 5 bars. 5 is usually the minimum. So right now we got 1, 2, 3, 4, 5, 6, 7. 7 is certainly an acceptable number. So with a bin width or an X scale of 2, it produced 5 bars. I'm sorry, it did not. 5 is the minimum. 1, 2, 3, 4, 5, 6, 7. Now, for the purposes of getting this onto paper, we don't want to go too obscure with this. What if we bump the X scale to 3 instead of 2? What would happen? So I'm going to go to Window, and what if we made X scale 3? So that makes each bin wider. Hit Graph. All right, that last bar looks like it got chopped off, so we probably have to go up to whatever that number was before in order to get them all to be the same width. So we'd have to go up to 108. Hit Graph. So we got 1, 2, 3, 4, 5 bars. So with an X scale of 3, that gave us 5 bars. Now, if we go even bigger with the X scale, it's going to bump us to less than 5 bars. So there's no sense going any bigger. If we go down to an X scale of 1, it might as well just be a dot plot. That's just going to be not very good. Just take a look to see what it happens if we do that. Window. Let's go to an X scale of 1. Hit Graph. It's kind of a meaningless feature. So you're definitely going to want to choose one of these two guys in order to show your final product. I'm kind of liking the one with the 7 bars. I think that was probably a better option. Good looking picture, good looking graph. There'd be nothing wrong with going with this one, but I think that's a little bit better. So I'm going to go back to Window. I'm going to put my X scale to 2. And I don't remember what that last number should have been for the X max. Yeah, we need to make it 1 less. Make it 107. Oops. All right. Now, any graph you create on your calculator, you can trace it. I'm going to hit the trace button right here. When you hit trace, up here in that upper left-hand corner, it tells you what you're tracing. So we're tracing plot 1, which uses data from L1. Down here, it tells you some values that are relevant to the graph. So we're in the middle of that first bin or that first bar. It has min of 93, max less than 95. So that means starting at and including 93, but up to and not including 95, there are 9 items in that list. Then you hit the right arrow. This bar starts at and includes a minimum of 95. goes up to and includes, not to, but doesn't include the 97, there are 5 things in that bin. And then if you trace all the way to the right, you can get all those values. All right. Now, if I need to get this onto my paper, if you draw the rectangle and then try to fill it in, unless you got some crazy art skills, it's probably not going to look real good. The better thing to do is to start with an L like this. Now we know that first bar, I'm just going to bump it slightly off the edge so I can get a better picture, started at 93 and went to 95. And we have a total of 1, 2, 3, 4, 5, 6, 7 bars. So that would be the end of the first bar, 2, 3, 4, 5, 6, 7. Space them out the best you can. Now the tallest bar went up to 9. So I need to get a good Y scaling here that goes up to about 9. So if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, so we'll go a little smaller than that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that first bar was 9. Let's go back over here to the tracing. So that was 5. So 8, 7, 6, 5 for the next one. 5 for the one after that. 2. 5 again. 1. And then that last one is 3. All right, any graph you're asked to create by AP rubric, you have to have your axes scaled. Now here, I don't necessarily have to fill in every tick mark. You want to do enough to indicate to the reader that they can easily scale things or scale the best they can. So both my axes are scaled. My axes need labels. This is points per game, and this is frequency. We should have a title, NBA scoring averages. If it is a histogram, the bars should touch. Bar graphs, remember, typically they do not. And we should have the bars all be of equal width. Now, drawing it freehand on non-graph paper like this, well, I think that's about as good as I'm going to do artistically. You're not going to have a ruler when you take the test for real. As long as you have reasonably decent scaling, you'll get full credit for that. All right. Now the instructions here said to create a histogram for the display. What if it wanted a relative frequency histogram? So instead of counts, they would want percents. So what we would have to do is change this scaling here. So we have a total of 30, right? 30 teams. Yeah, we have a total of 30 teams. So 9 of the 30 fit this category. So we'd have that top bar be right around whatever 9 divided by 30 as a percent is, and then scale down from there. And in the interest of time, I'm not going to go through those details at this stage. That'll be something you'll need to figure out on your own. The calculator is not going to directly give you a relative frequency histogram. You'd have to take the regular histogram and then convert over that Y scaling to percents. All right. As far as describing this graph, we've talked about different things that you would want to discuss when describing a graph. This here, I would say, is clearly classified as skewed to the right. That's where the tail is over here. You could call it that it has a single peak. Unimodal is kind of gray. If it was just one number that was represented by this bar, it'd be safe to use unimodal. But since there's several or a whole range of numbers that fit in here, I think single peaked would be better. So it's a single peak graph that's skewed to the right would be the best shape descriptor. As far as, here, let's write down the socks. So shape we addressed. We do not have any apparent outliers. The spread, the easiest thing to go with here would be we can actually state the min and max difference and give an exact range. If we didn't have the raw data and all we had here was this graph, we'd have to say the range goes from about 93 to about 107, because we don't know where in the bar the smallest number is, where in the bar the largest number is, without the raw data. So without the raw data, the best we could do would be to give an approximate. Now, as far as center goes, we did the one variable statistics. We calculated when we did that the mean and the median. Pick one of those measures of center to report. Okay, without that, what we would have to do would be to estimate about where the median was by looking at this graph. So if there are 30 NBA teams, the 15th and 16th teams would be the two teams in the middle. So the first 9 are in here, the next 5 are in here. So it was 9, 5, that's 14. The 15th and 16th teams have scores somewhere between 97 and 99. So without the raw data, if we just wanted to estimate a median on this graph, the median would be somewhere between 97 and 99. All right, I'm just going to take a quick peek at my notes that are off to the side here and see if that covers everything. What I did not mention in the beginning, I don't think I'll emphasize it right now, that if you're creating a histogram, histograms are meant for quantitative data, where these are numerical values. Bar graphs are meant for qualitative data or categorical data, where if you were putting them into some type of category, like teams in the region of the country, like Northeast, Northwest type of thing. So for the numerical data here, it's appropriate to do the histogram. In terms of visual impression, the histogram should have the bars that you're drawing touching. For the categorical data with the bar graphs, they should be separate from each other.